Hello everyone, welcome to the Cychem channel. Today we will learn about aromatic and non-aromatic compound with a small experimental examples. Let's consider two examples. One is aromatic, that is we took benzene, and another one is non-aromatic, we took it cyclohexane. In the both the case, the number of carbon present is 6 and the number of hydrogen present is 6 in case of benzene and 12 in case of cyclohexane. So let's fire it and we'll watch the difference. See, in case of aromatic compound, you can observe that lot of soot is coming on the top of the flame and it is formed some yellowish flame and top of the flame is lot of soot is coming. But in case of non-aromatic compounds, the flame is very clear and soot is very less in the top of it. You can easily observe here the soot is very less, but in case of aromatic compound, that soot is very high. Then what is aromatic compound? Aromatic compounds are cyclic compound which contain alternate double bond and single bond. That means it contains the pi electron delocalized all the way around them. So we see the example here in case of benzene. You can see these are the double bonds and single bonds. These double bonds contain one sigma bond, one pi bond. Okay. And the next one is the carbon hydrogen ratio is high. If you think in benzene, the carbon ratio is C6H6. So the carbon and hydrogen ratio is 6:6. Okay. And the other thing, if you burn that organic compound, that will form a strong sooty yellow flame. If you see here, we're burning benzene. A strong yellow sooty flame is coming. Here you can see the black things. This is called sooty flame. Okay. And the other thing, that a cyclic compound or that cyclic compound is containing alternate double bonds, single bonds or pi bonds, that must satisfy the Huckel's rule. If you think what is Huckel's rule, the Huckel's rule says the organic compound or cyclic compound that must contain 4n plus 2 pi electron. 4n plus 2 pi. If you calculate here, we can see 1, 2, 3 pi bonds. 3 pi bond means 6 pi electrons are there. So 4n plus 2 pi is equal to 6 pi. Then n is equal to 1. So always n should be 1, 2, 3, 4 like this, or maybe it is 0, but it must not be 1.5, 2.5 or any fractional number. So the organic compound or the cyclic compound which containing alternate double bond and single bond must satisfy the Huckel's rule also. The next one is non-aromatic compound. Non-aromatic compound means it will not follow any rules like Huckel's rule or any rules that is used for the organic compounds. The non-aromatic compound may be a cyclic compound or may be a acyclic compound. It may contain double bond or may not contain double bond. Okay. So this is the non-aromatic compounds. If you burn that non-aromatic compounds, that will not form a huge sooty flame. The flame is very clear. You can imagine in case of organic compound, you see a lot of soot is coming in the top of that flame. But here in case of non-aromatic compound, the soot is very less because the carbon hydrogen ratio is very less. If you consider that carbon and hydrogen, the ratio of carbon is less as compared to that of the hydrogen. Just compare this example, cyclohexane C6H12. Okay, the carbon ratio is 6 but hydrogen is 12. But in case of benzene, that is C6H6. 6:6 carbon to hydrogen ratio. So because of the high content of hydrogen, the flame is very clear, soot is very less. We'll do calculation for the percentage of carbon present in an aromatic compound. Here benzene, we will consider the benzene, and a non-aromatic compound we consider cyclohexane. Okay, the formula of cyclohexane is C6H12 and total mass is 84. So carbon percentage is total mass of carbon divided by mass of hexane, cyclohexane. This is not hexane, this is cyclohexane. and multiplied by 100. So if you calculate, you will find that 85.7% carbon is there. If you calculate the percentage of carbon in benzene, that formula is C6H6, then they will find that 92.3% of carbon is there in benzene. Both contain C6, but the hydrogen content in case of cyclohexane is higher as compared to that of the benzene, that is an aromatic compound. That's why, though, because of the high content of carbon, it is formed soot flame. But it is formed because of low content of carbon in case of non-aromatic compound, the flame is very clear and soot is very less. So thank you very much for watching.